Okay, number 6. We've got a function, and it looks like an exponential function. So exponential functions are always of the form y equals AO, the initial amount, times the common multiplier, which is 1 plus the percentage change in decimal format, raised to the x power. That could be time, whatever it means in this case. So we have 5 is the original amount. Our multiplier is -1. That means each term, to get the new term, is multiplied by -1 times the previous term. So our sign is going to change every term. So if that were x to the 0, so let's do x and q of x, just a quick table so we could see. If x is 0, 1, 2, 3, when it's 0, that's 5 times 1. So it's 5. And when x is 1, it's -1 to the 1, which is -1 times 5, -5. And when x is 2, it's -1 squared, which is +1 times 5. And then 3 is -1 to the 3 is -1 again times 5. So we can see every even exponent of x is going to be +5. Every odd exponent is going to be -5. Q of 6, that means x is 6. It's an even number. So as an even number, we're going to have a +5 value. Must be the case in this function. Correct answer is C, +5. Okay, number 7. X minus 4 times x plus 2 over x minus 4. Which value is a solution to the given equation? Okay, well, the domain does not include +4, so the answer definitely can't be that. Otherwise, your denominator is 0 and the function is undefined. But x minus 4 over x minus 4 cancel, assuming all real values of x, not 4, and the function becomes x plus 2, or the equation becomes x plus 2 equals 0. And be careful of the plus and the minus on the 2's. If we solve for that, that means x equals -2. So which value is the solution to the given equation? X equals -2. Now I'm going to check that. That's going to help. -2 plus 2 equals 0. That equals 0 on the right side. The equation checks. Okay, number 8, we've got an upside down parabola or downward opening parabola. It looks like our vertex is 6, 4, and we've got intercepts at 4, 0, and 8, 0. Let's just make sure these are zeros on the graph, and always note the grids. It's 1 by 1 for each square, okay? Not always the case on the SAT. Okay, so what is an equation of the graph shown? Well, we've got vertex form equations, which is always of the form y equals a, same leading coefficient of the standard form of a quadratic, a, x minus h squared plus k, where h comma k is the vertex, okay? So what should this equation be? It's going to be y equals a times x minus 6 for the h value squared plus k is 4 for the k value. And we just need to figure out what a is. Well, let's look here. This is going to be wrong right away. This is going to be wrong right away. And this is positive a, in other words, essentially 1, that's upward opening, that's going to be wrong. I don't even need to figure out a. C is going to be the correct answer. It's the only one that would have a negative leading coefficient, a, and be downward sloping, or downward opening. Okay, number 9. Right away I can see we're looking at what is probably similar triangles. And let's take a look. ABC is similar to ADE, they're telling us. So this triangle is similar to that triangle. The measure of ABC, that is this angle here, the B is the vertex, that's 60 degrees. What is the measure of ADE? Well, that's that angle there. Note, these are angles that are along transversals of parallel lines, which must be the case if they're similar triangles, which means these angles must be congruent. Corresponding angles, which is what these are, if I switched it around to the side, I'd have something that looks like this, and the angles would be that and that. They're corresponding angles of a transversal of parallel lines. Or another way to say it, the corresponding angles of similar triangles must be the same because similar triangles have all the same interior angles. So the measure of angle ABC, or the measure of angle ADE, must be equivalent to ABC, which is 60 degrees. Correct answer is D for number 9.